Assalamualaikum and very good evening to all of you. Welcome back to our class, the BAA2213, the Reinforced Concrete Design 1. In our class today, I will discuss about the design of flange sections of the beam. Okay, which means a beam which consider the specific width or specific width from the slab. Okay. So let me, okay. Can you see my screen now? Okay. Okay, so I hope you are ready with this, okay, exercise. Okay, let's have some changes. Okay, this one is exercise, let's treat this one as exercise number 5. Okay, which is from example number 1.4 from your textbook. And we will do this one. This is our design data. Okay, the D prime is 50, B is 700 mm, 100 mm for HF, which is the thickness of the slab. BW, we change BW to 250 mm. Okay, 250 mm. So here BW is 250 mm. Okay, you can write down the data. And then I want this one, the compression reinforcement is 3H12. Okay, I want to change to 3H12. And then the FCK is still 25. FYK is 500. D is still 500. Okay, so this is our design data. So please write down. I give you about 1 minute to settle it. Okay, the shape like this will become like this one. Okay, 3 and 6. Okay, this one. Okay, at the top part for compression is 3H16 and at the bottom part for compression is 6H25. This one is for compressions. Okay. It's okay, you can refer back to this notes later. Okay, so let's do it together. Okay, have you finished write down the data? Bring it here. Okay, exercise number exercise 5. Okay, so this is the data. Okay. D prime is 50 mm. D is 500 mm. The B is 700 mm. BW is from the beam is 250 mm. I changed this value. And then what is HF is equal to 100 mm. Okay. S prime is equal to 3H16. May I know the S prime? The area of steel?
603.
Okay, good. Thank you. 603 millimeter square. And how about the AS? 6H25? 24?
2946.
2946 mm square. Okay, thank you. So the solution is okay, FCK is equal to 25 Newton per millimeter square. This is the concept class. You don't have to remember the equation. Actually, you have to remember the concept. If you remember the concept, then you will get to know the equations. Meter square. Okay. So the solution is, let us go jump to the solution. You must understand the diagram first. Okay. The tips is you must understand the diagram. Okay, so this one, okay, this is the diagram, let's say. Can you see? I hope you can see. This is the beam with a flange. Sorry, it's not to scale. It's not to scale. Okay. And then this is the beam, T section of beam, and then this is the HF is here. The HF is equal to the thickness of the slab, and then this is the B. Okay, considering the width of the considered slab and width of the beam. This is the width of the beam itself, which is the BW. Okay, and then you must draw the stress block. Okay, the stress block. I hope you don't stress with this subject. Okay, this is the stress block, the shape of the stress block. Let's say I use the purple color. Sorry, okay, this one, let this. Okay, the stress block is here. Okay. Sorry, yeah, this is the stress block. Okay. You can use your ruler. Okay, it's okay. You can use your ruler. Okay, this is the for compression part. Okay, this one. And then, of course, this is the red color here is for, okay, 1, 2, 3, 4, 5, 6. Okay, you must know the concept. Okay, you must understand the concept. This is very, very important. So, I use a red color for this one. Okay, what is the red color now? F what? F. Just recall back your knowledge from F.
ST.
FST, yes, good. Okay, the forces inside the forces from the steel due to the tensions. Okay, and okay, let me do. Okay, this is okay like this from here to here. Okay, from here to here. So the distance is equal to what? From here to here, the distance, okay, from to the bottom, okay, to the center of the steel. The distance is known as D. Okay, this is the D. Our D is equal to 500 now. Okay, 500 here. Okay, and then since we have a compression reinforcement, means we have from here. Let's say the information given is we have compression reinforcement. So compression reinforcement is located. Okay, let's say I use the orange color. Okay, orange, blue, black. This one lah. Okay, yellow lah, yellow. Okay, yellow color here. From here, let's say we have a reinforcement here. This is our reinforcement. Can you see? I hope you can see. Yellow color. This is the okay. So this one is located here. Okay, let's say this originated here. Out to here, this is the F what? Anybody know?
FCC.
FCC?
FSC.
Yes, good. FSC because it's from the steel, but due to the compressions. And then here, from the top here to the center of the steel for the compression is what? D?
D prime.
Yes, good. This is our D prime, which is equal to 50 in our case. Okay, this is the D prime. Okay, and then what else? So we have also the compressions from the from the main beam. Okay, this one. Okay, I use the light blue. From this one. Let's say the let's say it's here. Okay, let's say it's up to here. Okay. So let me do some corrections. Okay, let's say it's up to here. Okay. The compressions here. Okay, so this is the compressions. Let's say from light blue color. This is the compressions catered by the beam concrete. Okay, concrete inside the beam. Okay, for compressions. So it will occur at the center. Let's say here the center. And here, let's say here, this one. Okay, F what here now? Anybody know?
FCC.
Okay, good. FCC1. Okay, let's say this is the FCC1. Okay, because this is area number 1. Okay, due to area number 1 here, this is area number 1. Sorry, I use better use another color. Okay, from area number 1 is here. Okay, this is area number 1. And area number 2 is here and here. Okay. From area number 2 at the center is here. Let's say I use let's say dark green. Okay, from here it acting on the center here, center of this slab. Okay, this is FCC2. Okay, you must understand this concept. This is very important. If you are going, the question number 1 actually for the beam design is derivation. So you must be able to derive either in midterm or the final exam. You must be able to derive. Okay, so how to derive the situation is you just must understand the concept. Okay, if you have compression, so you have FSC, compression reinforcement. If you have compression reinforcement, then you must have FSC. So this one is the center. Let's say the center here. Okay, and then this is the center of the center for this one. Okay, from this center from of the slab here. Okay. So you must be able to understand that this is the, okay, let's say this is your neutral axis. Okay, neutral axis is here, which is below the flange. We assume it is below the flange. If the neutral axis is in the flange, the design is automatically by rectangular section. Okay, just remember that concept. Okay, so this is from here to here is our X. Okay, from the top of the beam to the natural axis is our, okay, the X. Okay, and let's say we assume that the here to here is equal to 0.8 of, okay, 0.8 of X. Okay, and then here is your, of course, your BW. Okay, for the beam. Okay, for the slab that is equal to B minus BW. Okay, so for this one, so we have to consider also the lever arm letter, the Z. Okay, here to here. Okay, we want to consider the moment through here. Let's say this is AST. Okay, the point of AST. Okay, area of steel. So the moment here is from FSC. Okay, let's say from FCC1 first. FCC1, we must to get the moment we must multiply by what?
0.4.
First let's say multiply by this one. Distance is, let's say the distance is let's say the distance is equal to Z1 now. Okay, I hope you can see this. You know how to draw this one. Okay, and then from FCC2 here, okay, the distance here to here is equal to Z2 to And then from FSC here to here. Okay, can I do it here? Here to here to the center of the steel is Z3. Okay. Okay, can you see this one? Okay, so I hope we can derive. Okay, what is the value of Z1? Anybody can help me? Z1 is equal to this is the center. Okay, I use this one. Okay, I use the color orange color. Okay. Okay, this is from here to here is D, right? From top to here is D. Okay, so it's equal to D. We want to calculate from CC1 here. Okay, we have 0.8 x, but here is the center. Center means here to here at the top to here is what? Half. Half means 0.4 x, right? So D here to here is D. D. So we want to get the distance of Z1 is equal to D minus 0.4 x. So D minus 0.4 x is the distance of Z1. Okay, do you agree with me? Anybody wants me to repeat? It's all about the distance. Okay, you see the distance is from top to the center of steel at the bottom is D. So D minus 0.4 x, which is the to get the Z1, okay, from the center. Okay, it's in the center here is 0.4 x. Okay, and then the Z2 is equal to, okay, anybody can tell me what is the value of Z2? It's still D here. This is D minus the Z2 is here from the center to the here. Okay, the center of FCC2 to here. So this is center is half of HF. So D minus HF divided by 2. Do you understand what I'm trying to say?
Yes, doctor.
Okay, so this is Z2. So this is half. Okay, HF over 2. Okay, so D minus HF over 2 is equal to Z2. So how about the Z1 now? Z3. This is Z3.
D minus D prime.
Okay, good. D minus D prime. This is very important. Okay, you must be able to imagine this concept, and then if I give you, let's say in the final exam, we give you the question is hollow section here. So you must be able to something FCC1, the value of FCC1, you must minus the hollow sections. That's the concept. Okay. D minus D prime. It's okay. We will take a look on that example later. Okay, maybe 2 or 3 weeks before the final exam, we will have a look. Okay, so then this. So we assume, what we are going to assume is, first assumption is still stress FST is the design yield equal to 0.87 FYK. And then the second one is the neutral axis is in the web, okay, which is the below the flange. Okay, so always remember, okay, always remember that the concept is the forces equal to pressure times area. Okay, so the first one, what we have is FCC1 is equal to pressure for, let's say, CC1 times the area of CC1. So equal to, so this one is just my additional remark. Okay, this is just additional remark for you, for me to explain. Okay. Okay, no, you are not find it in your module. This is just further explanation from me. So the pressure here is always for the concrete is equal to, let's say, okay, the concrete is 0. Very simple, 0.567 FCK, okay, times the this one is BW, the area of this one. Here is BW here, the area of CC1 times 0.x, 0.8x, this one, okay, this is the area of CC1, okay. So this is BW, then this is the 0.8x. So times 0.8x. So equal to 0.567 times FCK is equal to what? Our FCK is 25 times our 0.8. Sorry, 0. This one shall be sorry, the area here is BW times 0.8x. Okay, so times, okay, this one, BW is equal to 250 times 0.8x. Okay, just let the value of x here. So what is the value of FCC1 now? Please use your calculator. Anybody can give me the answer? The answer will be in form of x here. What is
2835x.
Okay, good. 2835x. Okay, this is our FCC1. Next, the FCC2 is equal to, similar concept, the area of these two. The area of these two. This is FCC2, the area of these two. Is the area, this, and also this area. Okay, so the width of here and the width of here is equal to, let's say this is B1, B2. So B1 plus B2 is equal to B, the whole B minus BW. B minus BW. Do you agree with me? And then you must multiply by HF, this one. Okay, how to get the area actually, okay? This one, B1 plus B2, okay? Get the area, this one, okay? So that number 2 is FCC2 is equal to, similar concept, pressure for CC2 times area of CC2 equal to this is standard 0.567 FCK multiplied by the area. Area is this one, okay? As mentioned before, B1, we need this distance B1 and B2 because we want to multiply by HF later, so we must ignore BW. So B minus BW is equal to B1 plus B2. So B minus BW multiplied by HF. Okay, because HF is here. Okay, the area is this side multiplied by this side. Okay, so the answer is equal to 0.567 multiplied by 25 times the B is 700 minus 250 multiplied by 100. Okay, what is the answer?
Doctor.
Yes.
708750.
708750. Any other answer?
637875.
637 8
875.
875. Yes. Any other gets the similar answer? This one, like this one?
Sama.
Yes.
Sama kan? Okay, good. Thank you.
Same
Okay,
pattern.
so the first answer 7 something. Please check. Okay, and then the third situation is the F. The third situation is F S C F. Okay, forces in steel due to compressions is equal to, this is very simple. Pressure. Okay, pressure of SC plus area of SC lah. SC is this area of apa? S prime lah. So equal to 0.87 times FYK. This is not plus, this is multiply actually. Multiply, okay. So multiply with the AS prime. So equal to 0.87 multiply with 500 and multiply by 0.603. So what is the answer now?
262305.
262
305.
305. Okay, good. Newton per millimeter square. And then situation number 4, if FST is equal to PST times AS. Okay, pressure times area will give you the forces. So okay, pressure for steel is 0.87 FYK. Just remember this one. Okay, and then multiply by AS. So equal to 0.87. It's okay. I will write down the value one by one. Okay, maybe quite boring, but it will help you. Okay, 256. Okay, what is the answer now?
One two eight one five
1281
510.
510. Okay,
510.
510. Okay. Okay. So we have all derive all these 4 value, okay, of relevant forces, and then in order for equilibrium, okay, for equilibrium, I hope you can imagine. Equilibrium. Okay, because we have this one, this is the, okay, I write down here, this very simple. Okay, the red color we have the red color here we have FST, and then we have what color? Yes, yellow, green, and blue. Yellow here is FSC. Green here is second one is FCC2, and then the blue, that blue is FCC1. So for equilibrium, it must be equal, okay? For equilibrium, FST must equal to FCC1 plus FCC2 plus FSC. So FST is equal to, what is the value of FST? 1 to something tadi kan? Okay. So I use red color here. FSC 1281510 equal to FCC1 is I use this color. FCC1 is equal to 2 berapa tadi? 2835x. Okay, and then we plus the FCC2. This one is 637.75. This one is 637.875. And what is the value of FC? Okay, what is the value of FSC?
262305.
262305. Okay, can somebody get me X? What is the value of X now? So X is equal to what? Okay, what is the answer? X.
134.51
134. Okay, 134.5. Okay, let's say 0.5 mm. Okay. So this is the value of X. So you can get the Z1. Okay. This is since this is lesser than HF. Okay, HF is 100. So the neutral axis below flange as assumed. Okay, and then we may calculate the value of lever arm. Okay, the lever arm is here. This is the Z. Okay, we can use the value of, okay, let's see this one. Okay, use the value of X. Okay, here, sorry. Okay, Z1 is, okay lah. Okay, calculate the value of lever arm. Okay, Z1 tadi berapa? Z1 is equal to D minus 0.4x. So equal to 500 minus 0.4 times x is equal to 134.5. So what is the value of D1 now?
Empat 6.2.
Okay, good. 446.2 mm. And then the value of Z2 is equal to D minus HF over 2 equal to 500 minus 100 divided by 2. Okay, what is the value now? Okay, what is the answer?
450.
Okay, 450 millimeter. And how about the Z3? Z3 is equal to D minus D prime is equal to 500 minus 50. So the answer?
450.
Okay, good. Thank you. 450 mm. Okay, so I believe we can have the... Okay, and then we have... okay, so for moment of resistance, so about this one. Okay, moment of resistance about here. That's why I want to get the moment about here. Okay, this is moment is equal to FSC1. Okay, FCC1. Okay, let's say moment of resistance here. Can you imagine this one? I hope you can remember this figure. Let's say here, I write down here. Moment of resistance around this point is equal to FCC1 times the distance, FCC1 times Z1 plus FCC2 times Z2 plus FSC times Z3. Okay, so this is the equations. So moment of resistance MR, okay, so MR is equal to FCC1 times Z1 plus FCC2 times Z2 plus FSC times Z3. So the value is equal to FCC1 is equal to 2835x times what? The value of Z. Z1 is equal to 446.2, and then X you can multiply with 134.5. Okay, plus FCC2 berapa value ni? 637 8 berapa tak ingat lah. This one 875. 875. Okay, thank you. 875 multiply with the Z2 is equal to what? 450, right? And then plus, okay, FSC is equal to 262,305 multiply by Z3, which is also 450. Okay, so we must get to know the value of level arm, and then please let me know the answer of moment resistance is equal to what?
Doctor, 575 kilonewton meter.
500. Okay, good. Thank you. 575 kilonewton meter. Okay. Because you must divide by 10 to the power of 6 later. Okay, you must do this one. So this is the answer for question exercise number 4. So this is quite complicated because during the final exam you got the question with the hollow here, right? So you must do something. Okay, it's okay. I will review the final exam and midterm exam later. Okay, but you must understood this concept. Okay, you understood this concept. Okay, where is the position of FST? Where is the position of FSC? Where is the position of FCC2? Where is the position of FCC1? And then the distance Z1, Z2, Z3, and then you can settle. So this one based on the forces is equal to pressure times area and the equilibrium concept. Okay. Thank you very much for your participations. See you in next video.